Hey guys, it's Mr. Kim here. Today I'm going to do a few review questions on Chapter 7, Solutions, okay? To start off, we need to know how to read these curves, solubility curves. The thing about these solubility curves, we need to understand a couple of things, okay? The y-axis, what does it say? It says grams of solute per 100 grams of water. So what does that even mean? It means that, okay, how many grams of solute, which also means salt. I like to use the word salt to refer to these solutes. How much salt can I dissolve in 100 grams of water? That is equivalent to 100 milliliter of water, okay? So let's see. Number one, it tells us how many grams of NH3. Okay, so first I'm going to go ahead and identify where my salt here is. NH3, here is my salt. Okay, the word I'm using, salt, it really does not apply to NH3 because it's a covalent, right? It's a compound that is made from non-metals, right? But I'm still going to use the word salt because it's the solute that is in discussion for this question, right? So how many grams of NH3 would dissolve in 100 grams of 80 degree? Okay, so I'm going to go ahead and find where 80 here is, okay? So it looks like my point of intersection is going to be right in the middle here, right? Okay, so what is that? That's about, let's see, 15 grams of NH3 that is going to dissolve over, what is that, 100 grams of water, right? So it tells me that at 80 degrees Celsius, this solute, which is the NH3, will dissolve up to 15 grams of it. Okay, so my final answer here is really just going to be 15 grams of NH3 as my solutes, okay? Let's move on to doing number 2. Okay, 2 is, okay, 300 grams of water is saturated with NH4Cl at 70 degrees Celsius. Okay, first of all, you need to understand that we have now 300 grams of water. This table that we have to the left side, right, the curves will only read to 100 grams of water. So what do we need to do when we have 300 grams of water this time? Let's go ahead and see, right? First, locate NH4Cl, which I have right here, okay? And at 70 degrees Celsius, which is right around here, okay? So if I zoom in, I know it's not quite 60, but you know what? What the heck? I'm just gonna go with 60. Why not? Okay? So 60 grams of, what is the solute? What is the salt here? Ammonium chloride, right? 60 grams of this salt will dissolve over 100 grams of water. However, this question is slightly different. We now have 300 grams of water. So how do we find this missing information up top? Okay, in case you haven't noticed, this is simply going to be like equivalent fractions, right? Which means proportions. How can we find proportions? Here's a quick way of doing so, okay? 100 times what is 300? Times 3, okay? Which means we're going to have to do the same thing on the top, times it by 3. So that simply gives me 180 grams of NH4Cl. That's it. That's all you have to do. Okay, that was easy. But however, what if the question asks, okay, well, let's say I don't have 300, but what, I only have 50 grams of water. What do you do? It's the same idea. You would replace this with 50 grams. How do we go from 100 to 50? That's divide by 2, right? So your answer is going to be what? 60 divided by 2 is 30 grams of NH4Cl. Okay, it's really proportions. Okay, so make sure you set it up the way that I have done just now and to find what the missing information is. Okay, so that's how you read these solubility curves. Now let's go on and doing some of these concentration questions. Okay, first you need to know the pyramid, the concentration pyramid, right? So here we have the number of moles for N on the top, and big M, molarity for concentration, and V for volume. Please be noted, the V here is always going to have to be in liters, okay, as for your units, all right? So with that in mind, let's go ahead and tackle these questions. What is the molarity? Ah, okay, so this one is looking for molarity. So this one I'm just going to color in. So what do I have remaining? What two variables do I have left? The number of moles over the number of volume, always in liters, okay? So it's really just plug and chug, okay? However, this question is not so much plug and chug because we are given 15 grams. Oh, that is not moles. So what do we have to do? We have to convert from grams to the number of moles by using what? Using the molar mass. Ah, okay, so how do we do that? Refer back to your periodic table. You're going to have to add up all the elements, right? So we need to know the molar mass of this RbNO3, okay? Rb is, let's see, periodic table on the very left side, first column, roughly 85.5, right? I'm just going to just round it up slightly, okay? And what about N? We know that N is for nitrogen. That is only 14. And what about O here? Each oxygen is 16 times 3 because we have 3 of that. That's 48, okay? So what is the molarity of this? 85.5 plus 14 plus 48. That gives me 147.5 grams over 1 mole. Okay, so what do we need to do here, guys? We need to make sure that we convert 15 grams to the number of moles, okay? So 15 grams, and since we have grams as my given, I need to make sure that grams is here in the denominator, right? Which I'm going to put down 147 point down here and simply 1 mole so that the units can go away. So that is 15 divided by 147.5, and it gives me, okay, 0. I don't know, 10. Let's just go with that, okay? That's my number of moles. Okay, all right, so what do I do, guys? I need to just plug everything in because I have moles, and I'm also given the volume, which is 1 liter of solution, right? So let's go ahead and replace that. I'm just going to delete that, and I'm going to plug in 0.10 number of moles. And the volume I'm going to delete because I have it. It's given to us, which is 1 liter, which my answer is really just going to be 1.01 M molarity as my final answer. Sorry, got a little messy. Okay. All right, let's move on to number 4 this time. I'm just gonna bring that down here because I need it, right? So let's go ahead and delete that. This question is asking how many grams are needed. Okay, so we're trying to find the number of grams. However, this pyramid, it really doesn't tell us the grams. However, it does tell us the number of moles. So if it tells us the number of moles, what can we go with that? We can go ahead and convert from moles to grams by using the molar mass again. So, okay, so let's go ahead and solve for N. So if I block that out, the number of moles is just going to be M times V. Okay, that's pretty simple, I guess, right? And everything is given, right? That's my volume, that's my concentration molarity. So all I really have to do here is just 2.5 molar times 0.5 liters. Okay, so 2.5 times 0.5, and I have 1.25, the number of moles, right? Okay, am I done here? Don't stop here, guys. You have to read the question carefully. We're trying to find the number of grams, so I need to convert this moles to grams by using the molar mass once again. Calcium chloride. Calcium is roughly 40, and again, if you don't like rounding, kids, just go with the decimal that is reported in your periodic table, okay? For the sake of time, I'm just rounding here and there, okay? Chlorine is 35.45, but I'm going to have to multiply that by 2, right? Because there's 2 chlorine, and that is roughly 71, okay? So if I add these up, that gives me 111 grams per mole, per 1 mole. Okay, that's pretty simple. So what do I have to do here? Just use the molar mass that I've just found. So since I have mole as my given amount, I want to have mole down here. 111 grams Moles cancel out. All right, so what's 111 times 1.25? So that is 138.75 grams of calcium chloride. Dunsies. Let's move on. Let's do one more of these questions, okay? This time we're trying to find volume here, okay? I'm going to bring this down once again because I need it. Okay, so let's go ahead and get rid of this. I don't need that anymore. For this question, it seems like we're trying to find the volume. Okay, let's go ahead and block that out, right? So volume is equal to number of moles over molarity this time. Likewise, if you read through, it seems like the concentration is given, the denominator. That's good. However, it's, again, grams that is provided. Oh boy. So that means I'm going to have to convert grams to moles, again, using the molar mass, right? So let's find the molarity. Hydrogen is going to be 1 per hydrogen, but there's 2, so I'm going to write down 2 here. Hope that's okay. And sulfur, what is the molar mass of sulfur? That is 32. And what about oxygen? We know that oxygen is 16 per, but there's 4. That's 60, what is that? 64, right? So let's go ahead and add those up, and that's going to be, what is that? 96, 98. So that is 98. 96, 8, yep, grams per 1 mole. Okay, so using this molar mass, I'm going to go ahead and quickly convert 8 grams. And I'm going to have to flip it upside down, right? Because my given amount is grams, so I obviously need grams down here, which 98 is going to go, and the other is going to go up here. Grams go away, so 5 divided by 98, that gives me 0.051 moles. Okay, so what do? I'm just going to bring my equation here, and I'm going to delete N with what I just found, 0.051 moles. And what is my molarity here? The concentration. It is provided 0.25 molarity. And that is 0.204 liters. Always in liters, okay? With these pyramids, do I have it written down up here anywhere? Yes, I do. See? With these pyramids, the volume is always going to be in liters, okay? So keep that noted, please. So moving on to number 7. Okay, so we're trying to find the solubility of these ionic compounds, okay? So using the 6 rules that's provided, let's go ahead and see if they're soluble or not. Barium phosphate. All right, so the key word here is phosphate, okay? According to rule number 6, any compounds with phosphate are insoluble, with the exception of, what is it? Alkali metals, the very first column, group 1 metals. Barium belongs to group 2. However, so therefore, I meant to say, this one actually would make it insoluble, right? Okay, now what about copper 1 nitrate? Okay, now the key word here, guys, is going to be nitrate. Rule number 2 states that any compounds with nitrate are going to be soluble. That one was pretty easy. All right, next one, sodium phosphate. Okay, phosphate is another keyword. Rule number 6 states that anything with phosphate are insoluble except when they are bonded with any of the group 1 metals. If you look to your periodic table, sodium, that's not K. I'm looking ahead. Sodium is Na, and that is, yes, indeed, a first group metal, which actually makes this very soluble. Exceptions, okay? Next one, potassium hydroxide. Hydroxide is the key word here. Rule number 5 states that anything with hydroxides are going to be insoluble. However, with the exception of what? The group 1 metals. Potassium, again, is a group 1 metal, which makes this a soluble compound, okay? All right, I hope that makes sense. And let's go ahead and try number 8 now, okay? So we are given the equations. Now we need to write the actual chemical formulas, right? Calcium fluoride, potassium carbonate, potassium fluoride. What I would do, step 0, okay, is to identify all the charges because they're going to be very, very useful. Okay, calcium periodic table, it belongs to group 2, so that is going to be 2 plus. Fluoride is going to be a 1 minus, right? So our goal right now is to make sure that they are what? 0, neutral, right? So in what ratio is calcium and fluoride going to bond? Definitely 1 to 2 ratio, so that the charges cancel each other out, right? So that is calcium 1, fluoride 2, just like that. My next step is refer to your solubility rules. Calcium fluoride is absolutely going to be aqueous because it's a common type of salt, and if there's no mentioning of these compounds anywhere, it's safe to say that they're soluble. Okay, moving on to the next one. Potassium is a 1 plus, carbonate is a 2 minus. What is the ratio that they're going to combine to? Looks like it's going to be 2 to 1 ratio, right? So K2CO3. Okay, let's refer back to the solubility rules. Carbonate, that is rule number 6. Carbonate will be insoluble except when they are what? Combining with alkali, which, yes, potassium is indeed an alkali metal. Also aqueous. That was easy. Also, a quick note of reminder, these reactants are going to be always aqueous. Okay, that's the whole point of these questions, right? We have 2 aqueous solutions. When we combine them, what do we get? Do we get solids or do we not get solids? That's the whole point of these precipitate questions, right? So just keep that noted. Okay, all right, let's move on to the products finally. Calcium is 2 plus, carbonate is 2 minus, so that's a 1 to 1 ratio. That's pretty easy. CO3. Okay, let's see. Solubility rules. Carbonate is the key word here. Rule number 6 states that anything with carbonate is going to be insoluble, except those with alkali metals. Oh, okay. Calcium is actually not an alkali metal because it belongs to group 2 metals, which is alkaline earth metals. Therefore, this is the one that will produce solids. Okay? Potassium is plus, minus, KFL. Oh, FL, KF. Okay, that's it. And this one is aqueous. All right, so what do we do here, guys? Your next step is to make sure, so we have done this, check that off. Make sure that everything is nicely balanced. So quick look, on the left side, I have 2 fluorines, right? However, I only have 1 fluorine here. So what do? I'm just gonna put a 2 in front here so that everything is balanced. Oh, that's it. How simple is that? Okay. All right, so let's go ahead and write our net-ionic equation, okay? Before doing so, you need to make sure to write the complete ionic. What does that mean? It means any aqueous compounds, you're gonna have to separate or dissociate, okay? So we're going to separate in, we're gonna separate them in ions, okay? So let's go ahead and do that right now. Calcium has a charge of a 2 plus, state is aqueous, and the next part is fluorine and has a subscript of 2. So that's gonna be 2 actually in front. It's an indication that there's 2 fluorines, right? So do not use subscripts with these aqueous. I repeat, don't use subscripts with these aqueous ions. Put the 2 or any other subscripts in front. Okay, same here, 2 K plus. And we got a single carbonate, also aqueous. All right, next part. Solid will not separate. Bring down solid the way it is because it is insoluble. It does not separate. And 2 K plus because it has the coefficient, right? And also 2, don't forget about this 2, F minus aqueous. Okay, that's the hard part. Now here comes the easy part. Identify the spectator ions. What exactly are spectator ions? Well, they're the ones that are just kind of sitting there and not doing anything, not involved in making this solid. All right? The ones that do not contribute to making this solid, which, how do you find them? If they repeat from the left to right of the center arrow here, it tells me that, well, it didn't do anything. It stayed the same. For example, 2K plus, 2K plus, they're completely they're completely identical, right? So you just cross those away. Same thing with 2Fs. So what are my spectator ions? Spec ions are going to be the F minus and K pluses. Okay? So therefore my net ionic are the ones that are not crossed off. Simply put, calcium, CO3, 2 minus, and these two combine to produce the solid. And this, people, is my net ionic equation. Thank you so much for watching, and I'll see you next time.